In this video, we're going to focus on finding derivatives. Derivatives of functions that you're going to see in your calculus course. We're going to start with the derivative of constants using the power rule. Whenever you have fractions, radicals, trig functions, sine, cosine, tangent, natural log and log functions, exponential functions, e to the x, product rule, quotient rule, chain rule, implicit differentiation, derivatives for related rates, inverse functions, and how to find the derivative using the limit process. So we're going to cover all of those topics in this video. So let's begin with the basics. The derivative of any constant is 0. So let's say if you want to find the derivative of 5, it's going to be 0. The derivative of 8 is 0. The derivative of pi is a constant, it's a number, 3.14, it's going to be 0. The derivative of pi raised to the e, that's 0. The derivative of like 4e is 0. Notice that there's no variable, there's no x or y. So the derivative of any constant is just 0. Now let's say if you want to find the derivative of x squared, you can use the power rule. So what you got to do is move the 2 to the front and simply subtract the exponent by 1. So the derivative of x squared is 2x. The derivative of x cubed is 3x squared. For x to the 4th is 4x cubed. For x to the 5th, 5x to the 4th. Now let's say if we had a constant in front of it. So let's say if you want to find the derivative of 4x to the 5th. Rewrite the 4 and simply differentiate x to the 5th, which is 5x to the 4th. And then multiply the 5 and 4, and then you're going to get 20x to the 4th. So let's say if you want to differentiate 7x to the 6th. Rewrite the 7, differentiate x to the 6, which is 6x to the 5th, and then multiply 7 by 6, and then you should get 42 x to the 5th power. We'll try one more example. 8x cubed. Rewrite the constant 8, differentiate x cubed, which is 3x squared, and then 8 times 3, that's 24x squared. Now let's say if we have a polynomial function. Let's say if you want to differentiate 4x cubed plus 8x squared minus 7x plus 6. So you just got to find the derivative of each one separately. So the derivative of 4x cubed is just 4 times 3x squared. The derivative of x squared is 2x. The derivative of x is 1. And the derivative of 6 is 0. So it's going to be 12x squared plus 16x minus 7. So let's say if you want to differentiate 5x, it's simply 5. 8x is 8. 12x, the derivative is 12. Let's talk about y. If you differentiate x to the first power, using the power rule, move the 1 to the front. So we have 1x, and then subtract this exponent by 1, you get 0. Anything raised to the 0 power is 1. So x to the first power is simply 1 if you find a derivative for it. So 7x is going to be 7 times 1, which is 7. Now let's talk about finding the derivatives of fractions. So let's say if we wish to differentiate 1 over x squared. How can we do it? The first thing you want to do is rewrite the function. So basically, we're going to move the x squared to the top. When we do that, the positive 2 changes into a negative 2. And so now we can use the power rule. We're going to move the negative 2 to the front. So it's negative 2, and then x, and then subtract the exponent by 1. Negative 2 minus 1 is negative 3. So it's negative 2x to the negative third power. Then bring the x back down so that the negative exponent will become positive again. So it's negative 2 over x cubed. Let's try another example. Let's differentiate 1 over x to the third power. So again, initially rewrite it. So this is the same as x to the negative 3. Then move the negative 3 to the front. So negative 3x, subtract negative 3 by 1, negative 4, and then bring the x to the bottom. So it's going to be negative 3 over x to the 4th. So feel free to try this example. 1 over x to the 5th, and let's say 7 over x to the 6th. So initially rewrite it. This is x to the negative 5. use the power rule. So it becomes negative 5x to the minus 6, and then bring the x back to the bottom. So it's negative 5 over x to the 6th power. That's the answer. So for this one, rewrite the constant 7 and bring the x to the 6 to the top. So it's x to the negative 6. Then differentiate this part. The derivative of x to the negative 6 is negative 6x to the negative 7. Now, move the x to the bottom and multiply these two numbers. 7 times negative 6 is negative 42, divided by x to the 7. That's the answer for that one. So now let's focus on differentiating radical functions. Let's differentiate the square root of x. Now you need to know that there's a 1 here and there's an invisible 2 if it's not there. This is the index number. So if you don't see anything, it's a 2. The square root of x is the same as x to the 1/2. This number becomes the denominator. And this is the numerator of the fraction. So now we can apply the power rule. So we're going to move the 1/2 to the front, and we're going to subtract the exponent by 1. 1/2 minus 1 is the same as 1/2 minus 2 over 2. So 1 minus 2 is negative 1 over 2. So this becomes a negative 1/2. Now what we need to do next is move the x to the bottom. So it's 1 over 2x to the 1/2. Then put it back in radical form. So 1 over 2 square root of x. Let's try another example. So let's say if we wish to differentiate the cube root of x to the 4th power. So first, convert it into its exponential form. This is the same as x to the 4/3. Keep in mind, this number goes on the bottom. Then use the power rule. Move the 4/3 to the front, and then we have x subtracted by 1. So 4/3 minus 1 is the same as 4/3 minus 3 over 3. 3 over 3 is 1. So 4 minus 3 is 1 divided by 3. And since the exponent is already positive, we don't need to change it. Let's try another example. The derivative of the 7th root of x to the 3rd. So let's rewrite it. This is the same as x to the 3 over 7. So move this to the front. This is 3 over 7, and then x. Subtract the exponent by 1. So 3 over 7 minus 7 over 7. 3 over 7, well 3 minus 7 is negative 4. So we have a negative exponent. So we're going to move this to the bottom. So it's going to be 3 over 7x to the 4 over 7. Keep in mind, this number is on the bottom already. And now convert it back to its radical form. So it's 3 over 7. This is the index number. So the 7th root of x to the 4th power. That's the answer for that example. So let's see if we can put this all together. So go ahead and find the first derivative of this function. 8x to the 5th minus 3 over x cubed plus the 5th root of x to the 4th. So starting with this, we have 8 times the derivative of x to the 5th, which is 5x to the 4th. Now for this one, we have negative 3x to the minus 3. So we're going to move the negative 3 to the front. And then we have x, subtract this by 1, raised to the negative 4th. And then here, let's rewrite it. This is x to the 4/5. Move that to the front. So we have 4/5 x, subtract 4/5 by 1. 4 over 5 minus 5 over 5 is negative 1 over 5. And then move this to the bottom. So we have plus 4 over 5 x to the 1/5. So now let's simplify. 8 times 5 is 40, so we have 40x to the 4th. Negative 3 times negative 3 is positive 9. And then move the x to the bottom, so 9 divided by x to the 4th power. And then plus 4 over 5, and convert it back to radical form, the 5th root of x to the 1st power, which is just x. So that's how we can differentiate that particular function. So now let's move on to the derivative of trig functions. So let me give you the equations that you need to know. So the derivative of sine to the u is just cosine of u times u prime. The derivative of cosine u is negative sine u times u prime. And for tangent u, the derivative of tangent is secant squared u times u prime. And